Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Listening? Yeah, we'll start with the lesson. Now 5 members are there. Let them join. Actually, we'll start with an NS2 programming. In the last class, I have told you how the NS2 architecture will work and how NS2 programs will be there. So as we have seen the architecture of that particular NS2, that is actually the NS2 NS files will be there. C++ files will be there in one hierarchical folders. The files will be there at one particular drive, and where we will call it as an NS folder or NS different with different versions, NS 2.3 or a 2.1 version, like that. Different versions will be there. So all C++ files will be there in that particular thing, and we will write a OTCL script. OTCL script we are going to write. What is this OTCL script? I told you that it's an object oriented TCL where we can define an object for a C++ files which is there in a NS folders. There we can define an object of means object for that particular file. Through that particular object we can handle the area variables of that, and we can call different methods, and you can create your own method. This is the one advantage of TCL, that you can create your own method and you can put that into the class through that particular object. So that things and all you can do here. First, in practical, when you install the NS all-in-one 2.34 package, how it will looks and how it will works and all, I will tell you in a online, which you can see. If somebody doesn't have an NS2 installation is not there with them, they can go for means you can see now this live video how to install the NS all-in-one package. So just a thing, it's a free software. If you go to the Google and if you type NS 2.34 software, if you type enter, you will get on a website where you can download NS all-in-one. What is this all-in-one? NAM animator, graphical interface, everything means graphical editor, everything will be there within that. So it will install all the packages in one shot. So that's a good thing. So individually also you can take, but as a student, it's better that you will go for NS all-in-one. So how you can do this particular thing and all, starting from website, how to download and how you can install in your Fedora, that I will tell you now. Now first I will share this screen only. Why? Because I want to show you that how you can download this particular thing. Just I'll take this. Just a minute. Yeah. Now we came here. Yeah. Now sharing is started. Now go back here. Now I'll go to Google. Just I'll click on a Google. Right. Now what I will type here? NS. Just a minute. Yeah. NS2. 0.34 download whatever is there. You can software free download, you can see here. Yeah, yes, sir. Free download. Usually you can go here, whichever is a NAM soft. I think everyone, you are seeing this particular screen here, right? Which website is good, I'll tell you. Yes, all-in-one is good. Let's go. Yes. Yeah, this is the one. NS all-in-one 2.34.tar.z. First, you should take out this particular file. Now, go to this particular website, right? See here, you're going there. You can see here, right? NS snap is there. So, download. Wait a minute. Check it out. It's here. It's on video. What happened? Just 1 minute. Private another website also check it out. Yeah, yeah, NS1 all in one, right? Just click on this. You can download this particular thing here. So I think download will start. Your download will start shortly. So download will start there, which you can see here below. And net problem is here. I think a weak net. So yeah, you have to do like that just for a sec. So NS all-in-one, whatever is there, if you click there, the tar.gz means tar.gz file will be downloaded to you. Now just I'll stop this sharing and I will go to the Fedora. So you take that and put it in a pen drive and you connect that pen drive to the VMware. Now I will share this particular VMware now again. Just a minute. We are back here where we are. Yeah. So just now I'll click here, share the window. Now I will come to the Fedora, right? Now again share. Yeah, now it has been shared here. Now you can see here, it will be there in this particular root, means I've copied in root. You can see here. See, this is NS all-in-one 2.34 tar.gz, which is there here. Once if you open this, it will be like this. So how to install this particular NS2 software, that today I am going to tell you. Just I will delete this. I already installed, but for your sake, just I will delete this particular software. Shift delete. So permanently I'm going to delete this, right? See how many files are there. 8,507 files are there, right? Now again, you'll start. Once you will get this tar file from the internet, once you have downloaded, so you put that in a router. Fedora 8 is required for this. You put in a router folder. Once you have put in a router folder, open that, means unzip that. So just double click on that. So archive manager will come. So it will ask you that for a unzip. Just select that particular file and tell extract. So when you tell a extract, it will be opened in a root only. Not a problem. Let it be opened in a root. Extract you can. So just if you click on extract, you have to wait for a minute. Why? Because it's a very large file where the extraction must be done. So you have to wait for someone. See, you have to wait like this. Wait, please. So you have to wait until it will tell extracting of a files has been done. Don't disturb that. Now see, 0 bytes is remaining. Everything has been done. Just close now. Now assume this NS all-in-one 2.34 file has been came here. Now once it has been come here, you should go back to the terminal and you should start installing this. Before going back to the terminal, you observe here what are the things it will be there in this particular thing. So here you can see NAM software is there, NS2.34 is there, and you can see TCLLL is there, and a bin folder will be there here. I think the install is there. So once if you do the install, automatically bin folder will come, and you can see here xgraph is there to do the graphs, and TK files is there, so where you can link with other softwares and all. Even a Python also you can link, like that it will be there. So just now we'll go to the terminal. I'll close this. We'll go with the terminal now. As you know that we are in a root now, the folder will also be there. Now go get into that particular folder. That is ls-2.34. Once if you are there in that particular folder, now you can type ls. See here, install file is there. Are you seeing there? Install file is there. Now what you have to do, you have to run that install file. That is dot slash, these points are very important, dot slash space install. Right. Now I will type enter. 1 minute. I think no space here. Install. Yeah, no space, just install, dot slash install. So it will start installing. Now you have to wait until the installation has been done. You must be very careful while installation has been going on. Here you can see different, are you seeing there different C files and C++ files. It is been extracting and it is going to install. And you can check there how the C++ files is extracting, and first it will check and later on it will keep on installing. It will take around some, according to me, sorry, it will take around some 10 to 15 minutes for a installation of this particular thing. And you can see different libraries. It's a very vast software, NS2, where you can work it out with even satellite programming, it's been satellite network programming, Wi-Fi network programming, wired network programming, and even with MANETs, that is mobile ad hoc networks also you can implement. So all the network concepts, whatever is there, you can work it out with this particular MS simulator, and you can evaluate almost all protocols of the network in this particular tool, and it will support that particular tool also. Now you can check here how the installation is going on. While if you observe carefully here, almost all C files it is going to install in its particular folders. In this way, the installation will be keep on going on. Just we'll wait until the installation completes. Yeah. Now observe carefully. This installation has been over. We came back to the hash prompt. So we came back to the hash prompt itself. Now you can see here you have to set a path. This is a very important step in installing a NS2. Now you think that you have installed NS2. Am I right? But whenever you want to work with a NS folder, it will be not possible to work in this particular thing. As they have suggested here, you can see you must put whatever this OTCL platform is there, and NS all-in-one lib is there, everything. The environment path variable should be set here according to this particular format. The best another format to set the means the another best format to set this path is one easiest way is there. What is that easiest way? See, in a Unix, whatever the commands, external commands is there, that commands, if it wants to execute, it has to execute from sbin only. We know that in a Unix file system, we have seen that in a bin directory will be there and sbin directory will be there. Bin is the one where all internal commands of a Unix will be executed, and sbin is the one where all other software or external commands, whatever will be there, that will be executed there. So if I take all executable files of this particular NS2, if I keep in a sbin, automatically from wherever, in whichever folder or in whichever file system of this particular operating system, I can use, I can work it out with an NS2. Then how to do that particular process? Here all executable files after the installation of a NS2, it will be stored in a bin directory. Now if I type ls here, you can see a bin directory has been came here automatically. In the previous thing, bin directory is not there. Now automatically a bin directory has been came here. Now when you go to this particular bin directory, copy all the files whatever there, means in a bin directory only executable files will be there. You copy all that executable files and paste that in a sbin. 13 executable files will be there in a NS2. How this thing will be done? You can see here, just I will open here, means I will go here, NS all-in-one, then bin, right? And see, this symbol icon will indicate that these are all the executable script files. Now select all this, means control A. If you press, all 13 items has been selected. Now control C, means all copied. Then what you have to do? Then close this particular folder also. Go to the file system, right? Unix file system is there here. Yeah, file system. Now in this sbin you have to search. Is this a sbin, right? Go to sbin. Go to sbin. Just you copy, you paste all that particular files. Replace it. Means already I have installed software. No, that's why it's asking for you. It doesn't ask this. So replace all that. Means you copy all that particular files in a sbin. Now, wherever you want, you can run a NS programs. How to run? How to check whether my installation has been done correctly or not? So now you are already there in NS all-in-one, right? Now you come out of that particular folder. Now you are there only in a hash directory, that is your root directory. To check this whether NS is working or not, just type a command, executable command of a NS simulator, that is NS, and press enter. Now you see you came to the percentage. That is, you can type a TCL script here. That this shows that the installation of a NS 2.34 has been done successfully. Until if it doesn't come here, if it tells NS is an unknown command, the path setting problem is there. Somewhat installation not done correctly. While installing, if you doesn't get this path, you may get some error and all. Then some error installation has been occurred. So that problem will be there. So reinstallation of that should be done. Now you come out of this particular thing. So actually to say the core part of the NS2 will be present in, I'll go to that particular stage, that is NS all-in-one. First we'll go there. And now you observe this particular means whatever the folders which are present in this particular. In this you can observe this NS 2.34 is there. Now when we go to this NS 2.34, that is NS 2.34, if you enter again, if you go to that directory, now observe this ls. Now observe this. What are this particular thing? DSDV in your languages, I will tell. You know already about this protocol. Am I right? DSDV is there already. You know about this protocol. DSR is also a routing protocol. AODV is also a routing protocol. Satellites means satellite communication setup you can do here. Like this, we had discussed with the different concepts, means different, say, mobile communication, how you can do, and NAM files, how you can create. Like this, different files will be there, or different subfolders will be there. Now, for an example, just we'll go with the DSDV, and we'll see what will be there in that. Why? Because DSDV algorithm, we know already how a DSDV algorithm will work, and we have did the DSDV distance vector program also, and in routing also we have discussed dynamic source distance vector routing. Already in theory also we had discussed. Now we'll go with that DSDV, enter. Now you see this, what will be there here? Now observe carefully. This is a fantastic thing. What is there here? That is a DSDV .cc file is there. One header file is there, and whatever DSDV object file is there, and rtable.cc file is there, and rtable.object file is there. Now you can see rtable dot routing table. This is routing table. Rtable dot h is there. So that is for every folder there will be a one C++ file. Of that, one output file will be there. That is dsdv.out file will be there. DSDV header file will be there. Now you can imagine you are going to call this DSDV, means if you want to implement this protocol in a TCL coding, you will call this particular DSDV class file, and so this executable file you are going to call, and you will assign that to one particular object. So in this way, if you debug this in one by one, see different types of queues will be there in this particular queue. Like this, TCL means different types of other TCL scripts and examples will be there. Different types of TCP protocols, how a TCP version of protocols will be there. Sensor networks, how it is going to work, and how a multicast is going to work. So all these means different components of a networks will be there like this as a folders. If you go inside of that, you can see the C++ files. So this is a one way of debugging this particular folders. Why? Because as a network engineers, you have to debug and you have to see the architecture of this particular NS2. Why I am telling this means if you create your own C++ protocol, means how to insert that into this particular existing NS2. Anybody, it's a free software. Anybody, you can contribute your own algorithms, your own protocols to this NS2, and you can make a pack of that, and you can execute this, and you can modify this, even this particular programs also, whatever is there. You can modify that programs also, existing one, and you can see what is a change in the results also. Just it's a C++ program. That's way the NS2 accessibility is very easy. Coming to the next thing, means how you can do the NS2 program and all. So coming to that particular, now I'll come out of this directories. No need to be in that directory only, just to show you how the architecture or hierarchy of a folders will be there. That I have given you one example, and you can still debug one by one folder. You can go and you can check what is pushback, what is give. One by one, you can check there. Not enough issues. Now, if you come back over here and you can create one new folder, that's a lab programs folder you can create, and you can execute one by one program according to the lab. Now, we'll go with one testing program, means a small testing program we will do. That is what in a previous class that topology is, we'll try to create that particular small topology, and we'll see how that particular topology will be executed. A small thing which we are going to see in this particular thing. You can check it out, that also. Otherwise, we can create our own small problem, and you can execute that particular problem. Not an issues. Just for a sake, what I will do here. we'll go with some drawing tools and we can check with that particular thing also, not an issues. Applications, this is graphs is a graphics and this which are connected accessories image manipulation. Programming collapse. Just to take this perhaps we'll try with anyone. Just I need to show you what topology here. That's it. Means particular topology I want to show you. Just I'll check this. So either like a paint it will work or not. Yeah, it's running like that. Will take anyone. So, yeah, also. Wait, I'll stop this one. Close all tabs. Just I'll stop this sharing. We'll go to the paint and we'll see there. Stop sharing. I'm back here, right? And I'll open before this, just a minute. I'll open that paint software. Right back here. Yeah, I'll share now again. Share this. Yeah, 100. Okay, assume just now we have taken some painting here. Just for a sec, I'm showing. Assume this is one particular node. I'll call it as N0. Assume N0 node is there, and here assume N1 node is there. Okay, just for a sec, I'm telling. Then here, let it be assume some N2 node is there. Then the connection should be there from M0 to N1 like this. And here the bandwidth for this, let it be some 5 MB, 5 MB bandwidth, let it be, and I will give some 10 milliseconds. This is a problem, assume. In exam also, the problem will be given like this for you. So assume this is a topology, right? So let it be this, and let it be here from N1 to N2, let it be some 1 MB of a bandwidth, 1 MB of a bandwidth, and assume that same 10 milliseconds I'm going to give you. Now, then what is our next thing here which we have to do? Assume that you should assume the packet size. That is the packet size. Let it be 1500 bytes. 1500 bytes. Let it be bytes. Just for a second. Bytes. Now, what this is a moment scenario. In a last class, I have told you that what is a moment scenario and what is a traffic scenario. This is a moment scenario. What is a moment scenario? How the nodes will be there in a topology and which node will be connected to which, with what bandwidth and what delay time it has been connected. So this is a one, we'll call it as a moment scenario. Then traffic scenario plays a very much important role. So assume that, so in a NS2 default, a node will represent only three layers, that is up to the network layer. And the transport layer and application layers will not be there. Coming to TCP IP, until only two layers will be there, that is .NET layer and the IP layer. So remaining layers you have to adapt only for host to host. That means everyone imagine in between all will be the nodes. Even when I am explaining OSI reference model, I have told you very clearly that in subnet only until network layer it will be used. Remaining layers, all the 7 layers will be used only by source and only by destination. Assume now N0 is a source and N2 is a destination. There is only one route is there via N1 only, the packet should go to N2. Now you can see here the bandwidth, whatever is there here, 5 MB is there. That means maximum data you can send here. So the time taken to send from N0 to N1 will be 10 milliseconds. And with the same milliseconds, only 1 MB is there. And what is the crucial thing for a N1 here? The 5 MB of a data what is coming has to go only in a 1 MB. What about the remaining 4 MB of data? Then how a queue will be maintained here? How means what type of queue you have to use here to maintain correctly? If you doesn't use any queue correctly here, what happens? The drop of packets will be more, quite natural. What I have given an example of that 6 LAN vehicles coming and joining in a 1 LAN vehicle. Assume 5 MB of data is coming and joining with a 1 MB, it should move. It will become a bottleneck there where congestion will occur in N1. This is my intention why I am giving this particular example only. Now, how to set in a traffic here? This is very much important. How to set in a traffic? The next part, that is moment scenario over, we'll go to the traffic part. First, you should go with an which either you are going for a TCP type of a traffic or UDP type of a traffic. In NS2, you can design with two types of a traffics. That is, one is a TCP and another one is a UDP. So you have to decide that. So assume that now, just for a sake, I will go with a TCP type of a traffic. And later on, we'll see how a UDP type of a traffic will also be there. Now, for a sake, now we'll go with the other layer I am attaching. I will call this agent as a TCP0. So you have to attach that. This is a transport agent which I am attaching to NS0 node. Here afterwards it will become host. Until then it is a node only. Right. So once you have attached the transport protocol, that is TCP, attachment has been done with the object called as TCP0. Then you have to attach the application agent. That is, what is the application protocol you are going to attach here? You have to tell that based on this transport protocol, this will be there. That is, TCP is there means almost all textual data transfer will be there. So you can use here FTP. Means usually we are going to use in NS2 that as an FTP 0. Don't think that FTP 0 is just a name, that's an object. You can ask me that, sir, why you are giving FTP 0 and TCP 0? You can give any name, not an issue. This name will be the object for that particular class file TCP, and this name is an object for a class file FTP. Now I attached, observe carefully, until here only IP is there, I attached the transport layer and I attached the application layer. Now I will tell that here FTP type of traffic will be there and it will go and it will go to the. Then destination also I should design like this. I should identify, otherwise destination will become killed here, means inefficient destination will be there. So here I have to specify That is, here always the traffic, whatever the source is sending the packets, the same type of agent should be there to receive here. You can't give a UDP, means UDP agent cannot receive the TCP packets. So you have to give here TCP sync. Here this is very much important. Why TCP sync? I will tell you. TCP is a source agent. TCP sync will be the destination agent. That is, whatever packets are coming here, it is going to sync at the destination. What do you mean by sync? It will be reduced, payload will be taken, and only the header part will be sent back here from N2 as an acknowledgement stating that it has received this particular packet. That's why here TCP sync is needed. Everyone, any doubt you can ask me in between also, not a problem here. Now FTP is not needed here. FTP from application where you are sending, that is needed. Now you are going to have this particular TCP sync. Once the TCP sync has been put at a destination, what you have to do, you have to connect this TCP to that TCP link. How you are going to connect? A virtual connection will be established from TCP to sync. This is a virtual connection. This is a virtual connection. What do you mean by virtual connection? Just connect TCP0 to TCP sync. It's a virtual dotted lines. How a real connection will be there? TCP0 is connected to N0, N0 is connected to N1, N1 is connected to N2, N2 is connected to TCP sync. But this TCP will communicate with this TCP sync always. End-to-end process. Imagine when I have told in a theory, end-to-end process to communicate end process, the virtual communication should be there between this. That means the header formats which has been created by this TCP should be known to this TCP sync, and the acknowledgement which is sending back by this TCP sync should be known by this TCP. That is called as a end-to-end process. So this is very much important. Why NS2 lab for you? You understood now that I am relating a theory also here. So this is one thing. So you have to do in this particular format. So always before doing any NS2 program, constructing this type of a layout is very much important. Why I used this? Usually I will do on papers. Every student, every user of an NS2 should do first what is the problem. So this is a problem scenario. For that problem scenario, you have to create a topology, right? I will write a first topology. How many nodes needed? 3 nodes needed, right? Write a nodes. What is the connection between the nodes? What is the bandwidth, delay time, right? And which is the source and which is the destination, then you have to identify. For a source, you have to fix again which type of traffic agent is needed, either TCP or a UDP based on application. If it's a media or means multimedia application, then UDP is needed. Once UDP is there, again application protocol will also change. That I will tell you later. Don't worry about it. Now, here assume that TCP is needed. For that, FTP protocol, file transfer protocol, we are using as an application agent. Now, the packet size should be 1500 bytes. Assume this is a problem which has been given, and we should do a TCL program for this particular program. Now, we will start doing a TCL program for this particular thing. Just I will close now. I don't save this. Actually, just instead of writing on paper, I've written on Paint. That's it. Don't save. Yeah, now sharing has been stopped. Now back here, and we'll go with again the simulation one only here, right? Fedora. Back here. Right. Now we came here to the Fedora open terminal, right? Now same thing, how you did a TCL script, same like that you are going to do the NS2 program. Now I will start with first example NS2 1, like that we can take and you can do it. Gedit ex, just for a sec, NS2 ex1 NS2. I will do like that. Right? .tcl is must. Keep in your mind. Why? Because that's the extension. We are using a TCL scripting. Enter. Now, The first step in a NS2 programming will be always set NS new simulator. What do you mean by this? I'll tell you. See here, in architecture of NS2 also I have told you that first you have to create an instance of a virtual simulator first. For that, assume there is a class called as a simulator. For that, we are creating an object NS. Now, under this particular object, entire our network components, nodes, links, and then traffic, movement scenario, everything will come under this particular NS. Don't ask me that why, sir, you are given a NS. Always you have to give NS. No, you give your own name, not an issues. Just it's a name. But this syntax, whatever is there in a square brackets, is very much important, right? So that is a defaulting. Every NS program will have this instruction. Without this instruction, no NS program will be there. This is a first instruction common for all your lab programs, all 6 programs. The common instructions I will write first for all 6 programs. Then individually how it will change, I will tell according to the problem. Next one is you have to define output. So you know that in a NS2, sorry, in a NS2, there will be 2 types of outputs. One is a NAM output and another one is a textual output. For both outputs, what your simulator, the simulator has to simulate, it will simulate in 2 ways. One is animation simulation and another one is a text simulation. After doing a simulation, the data should be stored somewhere where it has to store. You will tell your simulator that you store in this particular file. That means we'll open one file in a write mode and we are going to tell that. How we are going to tell that? That is set. For example, you take any one file pointer. For example, for a name, I will take as a name, just it's a name. So then I will tell open, you give any of the file name, that is out.nam I am going to give, open in a write mode. So once it has been opened in a write mode, you should connect this file pointer, whatever nm is there, you should connect that to the simulator. How the simulator you know here is, that is a NS, that is $NS, whatever a simulator object I have created, in that whatever a NAM trace is there, that is NAM trace all. This is a command. NAM trace all is a command. Whatever animation trace is there in my entire simulation, that is a command, nam trace -all. You connect that to $nm. Through the file pointer, it will go and sit in out.nam. This is the default step. Coming to the next step. That is, next is trace file. That is a textual file. Set that is trace file means you can take NT means network trace file. It's left to you, whatever name you can take. Then open out.tr, usually we'll give for a trace file tr as an extension. You write it in a right. Now $NS whatever is there means in my present object of simulation, that is what name I have given for that is NS. So in that simulator, so trace all, NAM trace all is for all NAM tracing, means animation tracing. Another command is there, trace -all. Trace -all is only the textual tracing. Whatever event tracing is there, that is trace -all. So that will be connected to the another file pointer, that is NT, right? So after creating these two, now 2 output files are ready with us. One output will be there in out.nam, one output trace file output will be there in out.tr. Now, so again, what is another common thing for any NS program is a finish function. So once my all simulation has been completed, what I should do? So this is a question arises always. Assume I will execute my simulation for 20 seconds or for 20 minutes. Assume after a 20th minute, what should be done? So this is question arises. So I will define a finish function. Finish function is a one function which will be run at last of the simulation. That is common again for all the programs. That is proc finish. This I told you that why proc is there while discussing a TCL, that we are defining a procedure or a function called as a finish. So without any arguments. So again, I am getting into that definition of a function. What is the definition? Whatever global NS NM and NT. Why this global? You know that if I want to use the outside variables, same outside variables in a function, then that variable should be globalized using a global function that I told. Now these NS, NM, NT are same as this NS, MT. Otherwise, it will be private. You have to keep in your mind. Now, what's the first command? So after doing all the simulation, you must flush the NS simulator, whatever is there in your RAM, that trace, whatever tracing will be there, that tracing should be flushed. So $NS flush trace, I think this is a command. Yes, the flush trace, $NS flush trace. Now whatever is there, it will go off. Then what you have to do next? Close $NM. That is you are closing the opened file of NAM. Then you are closing the NT, that is trace file closing. You should close that particular files. Then what you have to do? Yeah, you closed all, means whatever is there in a memory, if you have flushed all that simulator and you closed both the files. Now your output is there in NAM and NS2. Now default, if you want to run your NAM file. So how you will run this NAM file default? Execute command is used to run a command within a command. So execute NAM is a command, NAM animator. File name you have to give. That is out.nam. You execute in a background, right? So once this TCL script has been executed, everything has been done. Once the finish function called, then after doing all these instructions, then it will start suddenly, means without initiating. Otherwise, user has to type nam out.nam. So what in my program, automatically a nam animator will come. You can see that, right? Now again, what you have to tell? Exit. Exit means come out of the program. So you close this function. There is no need to call now this. So all these above instructions, whatever is there, this is common for all the programs. Any NS program, whatever is there, it should be closed. The last instruction of any of the file here, means any of the NS programming file should be closed with this instruction NS1. If you doesn't have this, what do you mean by here? From beginning I'm doing all these things. I defined a simulator, I defined the output file, and then I defined some nodes, then I defined the connections, then I defined some traffic, then I scheduled some timings. Afterwards everything I did. You should run your simulator, right? So running simulator is a last instruction. Usually students will forget this. If you forget this, your simulation will not run. So that is a one important thing. Now that's the last instruction. So in between these, what you have to do. Now go back to problem. Now you should think about your problem. What is your problem that we have designed in a point you have seen? That is, first in your problem, how many nodes are there? We know that there are three nodes are there. First, create nodes. How to create a nodes? That is, set n0, means the first node you are going to set $NS. In my simulator, node is a command. So set one node. After creating a node, the node will be set to N0. You go with the next, that is set N1. So next is $NS, same command. That is node. How many nodes you want? That many nodes you want, you can set to different variables or different name of the nodes. N2. That is $NS that is node. Now close this. One, you have created all this. It's going, time is going up. Just 10 minutes more I'll take here. So it's going out means you have created a particular nodes. What is the next? You have to create a links. How will you create a links? $ns in my simulator. I need a duplex link. Duplex link means two-way communication link I need between which nodes? That is $n0. If I give only n0, that is characters, no value. So $n0 and a n1. Between starting from $n0 to n1, I need a duplex link in my simulator. What is the bandwidth? 5 MB. 5 MB of bandwidth and 10 milliseconds. 10 milliseconds, 10 minutes. 10 milliseconds. 10 milliseconds. Then you have to set a queue, that is drop tile. Drop tile, right? Then another link, only two links is there. That is $ns duplex link again from n1 to n2. Now what is the bandwidth here? 1 MB. M is capital, keep in your mind. And same 10 milliseconds. Assume queue type you are going to use here is drop tile. Right, now the connections are over. Now you should set a traffic, means how a traffic will be set here. So that I will take in a evening class. So evening class will set with again at I think you are free in a evening. You are having 3:30. I think you are having a Java class, right? When we can take a class? Anybody listening? When we can take a class? Today? It's possible?
2:30.
4:30 can I take?
So in between, like before
4:30
Java
can I
class,
take?
you can take.
Before Java class, you don't have anything?
No, sir. We have now OS class like 11:45.
Afterwards?
No, no, sir. Afterwards 3:30.
Then 2:30 I will take a class.
Okay.
Okay?
Okay, sir.
I think for you it's possible. Any problem is there?
No, sir.
ಹೇಳಿಪ್ಪ.
No, sir.
Okay. Today I will show you how to run this particular NS2 program. Why? Because it's lab programs you can do easily afterwards. Okay.
Okay, sir.
Again class. Thank you very much.
Thank you, sir.
Thank you, sir.
I will save here only. We'll continue from this particular part in a next coming class at 2:30.
Okay, sir.
Okay. Then I'll stop sharing this particular thing.
Thank you, sir.
Right. Then I'll close this. Yeah. Now, thank you very much.
Thank you, sir.
Stop.